In my last video, I show you how to write a quantum circuit using Qiskit. But I'm sure that you're wondering how to actually take that quantum program and run it on a real quantum computer. Quantum computers have existed since the 1990s, but until recently, they are only accessible to researchers in labs. Today, quantum computers still require special equipment and maintenance, but thanks to the development of cloud technology, anyone can access our quantum computers through the cloud. Today, most of the real-world quantum applications uses some kind of interplay between the classical and the quantum resources. That is, sending my circuits to the real quantum hardware for execution is only half of the story. Once the circuits are done being run, the quantum hardware returns the results back to my laptop. My quantum program then does some kind of classical processing. And the output of this classical processing is then used to generate the next sets of circuits to run. Unfortunately, this is a very inefficient model because my real-world application can have hundreds of iterations. And for every single iteration, the circuits need to be sent all the way to the quantum hardware, which can be extremely far away. It then needs to wait for the result to again make the return trip just to generate the circuits for the next iteration. It is spending more time on the data transfer than actual execution. And this is why in 2021, IBM introduced Qiskit Runtime. Qiskit Runtime takes quantum programs and all its dependencies and package it in a containerized execution environment. This environment is close to the quantum hardware, so it can reduce the latency by creating a tight loop. And because the program runs on the cloud, it also improves the scalability of classical resources. But there's more than that. Your programs now run in the cloud and can get all the benefits of a cloud-based model. Most notably, Qiskit Runtime offers a set of tools and features that would make quantum computing easier for developers. It has a number of predefined routines, such as circuit optimization, that remaps the gates in your circuits so they would run faster, similar to what modern compilers do. Circuit result post-processing that would take all those measured ones and zeros and convert them into higher level representation, such as expectation values. And the last one is error mitigation. That gives you higher quality results. The error mitigation is especially important because quantum hardware today is not perfect, and the raw results often contain errors. So without error mitigation, you wouldn't be able to get the correct results back. So how do you actually access Qiskit Runtime? The answer is simple. You use Qiskit. Qiskit has a package that allows you to send your entire quantum program, including both the quantum and the classical piece, into this execution environment. Thanks for watching. If you have any questions, please leave them in the comments below. Also, please remember to like this video and subscribe to our channel so we can continue to bring you content that matters to you.